Okay, so this is part 2 of um, question C. So question C says triangles A, B, C, and D, E, F are similar. So we know that these two shapes are similar to each other. So important to note, they are similar. Very, very important to know that similarity has rules to them. So we need to find the missing side lengths. So find the missing side lengths. Okay, and angle measures. We got to find both. Okay, so what I'm gonna do is I'm gonna identify a couple items here that we know match already. We know that this angle here and this angle here are congruent to the same measurement. Okay, and if you look at the way they're written, A and D both come first, so those should match. We should know that B and E are pairs, so these two should match. But we don't know either one of them, so we got to figure out one of them. Once we find out one of them, we should know the other. Lastly, we have C and F, they match, so these two should match. Hey, look, we know one of them. We know what C is, so we can kind of fill that in already and know that this one is 94 degrees. So if we know that's 94 degrees, we know that our triangle sum theorem is that every triangle equals 180. So I can say that 180 degrees minus 56 minus 94 leaves us with a grand total of that's 10, and that's 1, it's 40, so 150. So we subtract 150, we have 30 degrees left. So we now know that this is 30, and since these degrees, and since these two are the same, these are also 30 degrees. Alright, so we got our missing side angles done. And we know that because they are similar, and similarity means they have the same angle measurements. Okay, let me clear off a couple of these items here. I'm going to get rid of these highlights here. Oops, just the highlights. So let's get rid of this. So that way we can identify some side lengths. So I have to figure out these two. So what I know is that we have some matching pairs. 6, the longest side, the second longest side matches the second longest side. So there should be some connection here. Whatever I multiply by, this is my scale factor, that's the number I want to use. Okay, so whatever number I use there, I'm going to use the same number to find this one, and I'm going to multiply by that same number that I used before, and 5 to this unknown, I'm going to multiply again by the same number. So I'm going to write these out here, first with the one that I know in red. 6, you know what, let's label this. Let's say side length AB times scale factor will equal side length DE. So those should match. Okay, so AB is 6 centimeters times something, and that's going to equal 7.5. Okay, and again, our scale factor is these two numbers, and we figured that out through fact families. 7.5 over 6. Okay, and I'm going to use that number again. So this is my scale factor. Actually, I don't like that color. This is my number that I want to use over and over and over again. Now that number doesn't look so good to me, so I'm just gonna reduce it if I can. I think I can reduce it a little bit. I know it's a little bit hard to identify, but I can identify by, I think, 1.5. So if I divide this by 1.5 and divide this one by 1.5, I think I can get 1, 2, 3, 4, 5 over 4. So we can make this 5/4 as our scale factor. Okay, that's the number that we want to multiply by to get all of our missing numbers. So let's start off with our 3. 3 times 5/4, and I can get this one over here. 3 times, and again, this is our number that we're looking for. This is our 5/4, our 5/4. Okay, on the side, I'll show you how I got the 5/4. Okay, so 7.5 over 6. And if I divide by 1.5, divide by 1.5, divide by 1.5, and then I end up with 5/4. Now we have whole numbers instead of a decimal on top of another number. So this is 3 over 1 times 5/4 will equal 15 over 4, and that's my missing number over here. Okay, now these are in decimals, so I'll just divide this and reduce this. 15 divided by 4 gives me 3, and I can get 12, subtract, and have a remainder of, subtract, get 3, and I can have any remainders, 0. 4 goes into there 7 times. 7 times 4 is 28. Subtract 2, 1 more 0, 0, and I get 5. 3.75 centimeters. So this one is going to be 3.75. Okay, I'm going to do this one more time with these exact same numbers. Okay, I'm going to scoot this over a little bit. Okay, and I'm going to do the same thing with these numbers, and I'm going to use that same 5/4. So 5/4 is my scale factor. I have to use my scale factor because that's what similarity has in common, is their scale factor. And I'm going to use it with this 5 just like I did with my 3. So I'm going to multiply this by 5 over 1. That's this 5 over here to get this unknown. 5 times 5 is 25 over 4. So 4, we're going to 25. 25 divided by 4, give me 6. 24, subtract 1, decimal, 0, 0. Twice, 8, subtract 2, 0, and 5, 6.25. 6.25. Okay, so there's C2. Use this to check your work, not to just copy down. It's a great way to check your work because you can always pause it and rewind it whenever you need to. Okay, nested triangles. Now nested triangles are interesting because there's actually 2 triangles when you only see one. Sometimes you only see one, but we'll identify 2 here. Okay, now yours is whited out a little bit, but we'll fill in the blanks as you see them. Okay. Triangles that share a common angle. So there are actually 2 triangles here. Let's see if we can identify our 2 triangles. Okay, so the first thing we need to do when we see nested triangles is know that they share a common angle. So these 2 are the same. They both have this same angle here. Now if they share that angle, they actually become, and these 2 lines have to be parallel too. If these 2 are parallel, then they are similar triangles. Okay. Now when we see nested triangles like this, and you'll see this in your homework on question number 25, the first thing you need to do is identify both triangles. There's the big triangle, and then there's the short triangle. Okay. Now, what I would like you to do is draw both triangles out separately. Okay. Now that way, when we draw them out separately, okay, redraw triangles and label appropriately with all known values, is that now I can kind of use my scale factor from one to the next. Okay, let me actually switch these places over here, be a little bit easier. Okay, so I know a couple things about my triangles. I know that the distance from here to here is 80. I know the distance from here to here is 120. I know that the distance from here to here is 140, and that's all I know. Okay, so what I want to do is use my scale factor, because nested triangles with parallel lines are going to be similar, is I'm going to use my scale factor and to compare my two items. Now these two side lengths here are going to be corresponding. They're the same part of the triangle. Okay, so I'm going to find out the scale factor from one to the next. Okay, so from one item, from 80 to 140, I need to multiply by something in order for me to get that 140. Okay, so once I figure out what that is, I can use this number again. Okay, I can use that number again. This is my scale factor. Okay, this is my scale factor. I can use that again to find this number to figure out this side length here. So this side length here should match this side length here, and I can figure out what the whole thing is. Okay, so let's do our math. Let's find our scale factor. 80 times something will equal 140. This number is going to be 140 over 80, which if I reduce everything, I think everything's divisible by 20. Divide that by 20, I get 7. Divide that by 20, I get 4. This is my scale factor. I reduced this number and got 7 over 4. So I can use this number again. These two again are the same. Now if you're not listening, if you're just copying this down, you won't know what I'm saying and you're going to miss out. These two are the same value and they both represent our scale factor. Okay, very, very important. This is our scale factor. Okay, I'm going to use these numbers again. I'm going to use it again and have my other known value to figure out my question mark. So I'm going to have 120 times 7 over 4 to get my unknown over here. So I can reduce this, and that becomes the 120 and the 4, that becomes 1. I'll divide this by 4 and I'll get 30. 30 times 7 is 210 over 1, or just 210. So the distance here is 210 for the entire length. Okay, now that's important to know that my entire length here is 210. Okay, now what I'm going to do is I'm going to get rid of this so we can see what this looks like. So I'm going to put this nested triangle back together so we can see how they relate to each other. Okay, so 210 is the entire length. Okay, 210 is the entire length of this big triangle. Okay, so what I'm going to do is I'm going to put this one back there, and I know this side length here is 120, and now this side length here is 80. Okay, let's group these all together. Okay, I'll put this back over here. See what it looks like. Now the question is, how far across is it from this stake 1 to this tree? Well, altogether it's 210, but from this stake 3 to stake 1, I already have that distance, which is 120. So to find out what's left, I'll have 210 minus the red. Okay, so to find the distance across the river, 210 minus this one, so 210 from here to here, and I'm going to take this part away, and I'm only left with this little section, minus 120, and that gives us a distance across the river of 90 feet. 90 feet. Okay, now I'm not going to do question 2 because I'm going to leave that up to you. You should do the same thing we did here earlier to solve this one. Find your scale factor using your known side length values, okay, of corresponding sides, and then use it again, to compare your unknown, okay. So when you see this, you shouldn't see your known values right here, okay. Once you're finished, your homework is the one that, one of the papers you picked up on the way in, okay. Your homework is going to be questions 9 through 19, 22, and 25. Number 25, this is the nested triangle question, okay? And then 9 through 19 and 22 is using scale factor and your knowledge of similar figures, okay? That should end our lesson for today. If I feel any better, or if I can speak any louder, then we can do a lesson together, okay? All right, let's get to work.